For those of you at home, you don't know this, but I just lost my projector in the classroom. Okay, I'm back. All right. Okay, so the next one we're going to do is this down counter. So we have to start with the 15 and then go down to 0 and then back to 15. Okay, so okay, yeah, so this is kind of interesting to think about it. Let's go back to that page where I have all my numbers. Is that here? Okay, so here I have all the binary numbers from 0 to 15. And let's think about what if I wanted to use my counter. I've got a very nice counter, but for whatever reason I want to count in the opposite direction. And I want to think about how I could go about doing that. And so I want to think about, well, what do the numbers look like going from 15 to 0? So I'm going to write those up here. So that's 15. 14 is, 14 is 1, 1, 1, 0. That's 15, 14. 13 is 1, 1, 0, 1. 12 is 1, 1, 0, 0. 11 is 1, 0, 1, 1. And 10 is 1, 0, 1, 0. Now, if you look, there is a relationship here between these numbers. So if you look at 15, 15, all of its bits are the complements of the bits of 0. 14 is the complement of the bits of 1. 13 is the complements of the bits of 2, and so forth. So that's kind of crazy and cool, and we can use that. And here's how we'll use it. So we can take just a regular counter, and load 0, and tell it just to count normally. We're not gonna change anything, except we're just gonna take the naught of each of our outputs here, and then this result right here, that will give us, so I don't know what to call it, but I'll call that Q0 prime, Q1 prime, Q2 prime, Q3 prime. Then that number will give us the count sequence that we want, and I don't have to do anything else to it, because that one will work. All right, and then the next one, are questions on that? All right, so the next one, I believe we're supposed to go from 0 to 128 and then back down to 0. All right, so this obviously is more than 16, so we're going to need 2 counters. And I believe in your homework, the one that you have to do, what's the biggest number in the one in your homework? 31. Okay, so you'll need 2 counters. So whenever you need a number bigger than 16, the first thing that you're going to do is you're going to take the AND of all four of these, and wire that into the enable of the second counter. And that is all you need to do, and we now have an 8-bit counter. So this counter now works as an 8-bit counter, where this first counter gives us Q0, Q1, Q2, Q3, and the second counter gives us Q4, Q5, Q6, and Q7. We want to use the same signal to load on both of them. So I don't know what that's going to be yet, but I want it to be the same on both of them. And what I want to load, since I'm starting at 0 and I'm skipping back down to 0, is I want to load 0. And then I want to detect 128. Well, 128 is 2 to the, let's see, 2, 4, 8, 16, 32, 64, 128, 2 to the 7th. So that number is 128. And so if I think about counting up to that number, the number I have before this one has all ones except for the Q7. So this is Q7, and Q6, Q5, Q4, Q3, Q2, Q1, Q0. So the only number that we have that has a 1 in the Q7 is 128. Once we get to 128, we're supposed to go back to 0. So all we have to do is to detect Q3, and as soon as Q3 is 1, then it's time to load again and get back to 0. And I can't get to my pencils. No. Okay, I can't erase anything. All right. My computer is saying it's ready to quit. What time is it? Oh, it is time to quit, almost. Okay. And the next one is 16, 17 to 64 and back to 16. Okay, so 2 counters. I should have drawn these ahead of time. But then I would be moving on ahead of y'all, and then I'd be going too fast. Okay, so let me look at what these two numbers look like. So 16 has a 1 in Q4. So that's Q4, Q3, Q2, Q1, Q0. And 64, that's the 16 spot, that's the 32 spot, this is the 64 spot, would have a 1 right there. Anything smaller than 64 does not have a 1 right there. So all we have to do for this one is load 0, 0, 0, 0, 0, and 1, 1. because that's the Q4 needs to be 1, 0, 0. So that's going to be our load. And all we need to detect is Q6. So this is equivalent on our second counter. That's Q4, Q5, Q6, Q7. So we just need to detect when that one is 1. And when that one is 1, that's when we want to do a load. And that would get us starting back up at 64. When we get to 64, it starts us back at 16. And the last one is 128 to 7. So anytime it wraps around, that's when you need to be a little careful. I don't think I drew this on my last one, but I should have. To string these two counters together, you do have to have the AND going to the enable. Pretend like the bottom one has a clock. Okay, and we're starting at 128. And we're going up to 255, and then 0, 1, 7, and so forth. Okay, so 128 has a 1 in the 8th bit and zeros everywhere else, so that's what we're going to load. So we're loading and then 7 and then 128 and so forth. Now when it gets to 255, it'll automatically go back to 0, so we don't have to do anything about that. What we have to do is tell it when it gets to 7 to load 128. So we want it to detect a 7. So a 7 looks like this. Now it's not enough just to detect when the last 3 bits are 1, because the last 3 bits are 1 several times in the numbers between 128 and 255. We need to think about what can we detect that is the first time you'll get to it at the number 7. Well, remember that from 128 to 255, all of those numbers have a 1 in the 128 spot. So since everything from 128 to 255 has a 1 in that spot, then 7 is the first time we're going to have a 0 in Q7 and 1s in the first 3. So what we want to detect, the smallest thing we can detect, are all 3 of these 1s in Q0, Q1, and Q2, and a 0 in Q7. So I'm going to take the AND of these first 3 bits and I'll AND that with the NOT of Q7, and I will make that the load. The only reason I used 2 AND gates there instead of 1 was just because my screen was crowded. Your directions say to use the minimum number of gates, and so in your case you would use 1 AND gate with 4 inputs probably. Rather than the 3 and then ANDed to the other one. All right. So I think that is the end of what I have to say. Are there any questions?
I have a question.
Okay, hold on. There's one here first, and then I'll get to you.
Okay.
So for the homework
I'm pretty sure. I read it a couple times to find out, and so the question was for the homework, are we doing just what we just did, but with the sequence that he gave you? And my answer was, I'm pretty sure. I read it a couple times, and he very much likes you to use his, the partial homework solutions to construct your homework solution. So I think if he wanted something different, he would have examples of it in the rest of the homework, and he doesn't. So I think this is what he wants. Okay, do you have a question?
So it's pretty much kind of the same thing. So if you were to like jump from like you get a Q output of 7 and then you go straight into like 18, do you just
Yeah?
like load the previous two with the 16 to get 18, or do you have to like do something different? Because we've only been doing uh like 16, 32, 64. We've only been loading those in, but we haven't like really combined them yet to get like a number between 16 and 32 is what I'm trying to say.
Uh, yeah, well, I mean, we did do some. You might not have been here, but like, I can load a 5 just fine. I mean, if I want to load a number between 16 and 32, it would look like this. So I'd have my 2 counters. So let's say I wanted to load 50. So I just need to know the binary number for 50. And let's see, this is 1, 2, 4, 8, 16, 32, 64, 128. So 50, that's 32. 32 plus 16 is 48, plus 2 is 50. So here's 50. So to load 50, oh, these are D's. These are supposed to be D's. I will have a 0. So this is the 0, 1, 2, 3, 4, 5, 6, 7. So I have a 0 at Q0, a 1 here, 0, 0, 1, 1, 0, 0. So you just load those numbers, and so let's say I wanted to count from 50 to 77 and then back to 50. Okay, so I'm loading 50, that's already taken care of. I want to stop at 77, so I need to figure out the binary for 77. So 77, that would be 64 plus 64 plus 8 is 72. 64 plus 16, so 64 plus 8 is 72. 72 plus 4 is 76, 77. I think that's 77. You could double check on that. So I want to look for this number right here, 77. So I want to see when am I going to have this as an output. Now the safest way is to take the AND of the not, well, the AND of, so this is Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8. So I could take the AND of Q1, Q3, Q4, and Q7 and the not of Q2, Q5, Q8, Q6, and Q8. If I take the AND of all of those, that will surely equal 77, but there's probably a way to get to 77 without having to check all of those, because at 77, I'm going to have a 1 here, and that's the 1 there tells me I'm bigger than 64. And let's see, I would want to write out these numbers. So I would write out the numbers for 65, 66, up through 77, and I would try to determine, what's unique about 77 that's not on any of the other values between 50 and 77, and detect that. So, like, for instance, let me think about it. So, 77, so this was 8. That is, so 64 and 8 is 72. Well, I could detect those 5, and that would be the only time that those 5 would happen. That would do it. You're not going to have that sequence on any of the other numbers between 65 and 77. So.
Yeah. Okay.
Yeah, but that's how you load it. You just put the number up there.
Yeah.
Okay. Any other questions?
So if you're like loading a number and then it jumps to a different number and then counts and then like loads the first number again, would you just do like what we did and then like another?
Okay, maybe I am missing something. Let me look at the homework. Okay, I see what y'all are saying now. Okay, I understand. Now I see what y'all are talking about. I thought his sequence was 0 to 31 and back to 0, and I couldn't figure out what y'all were talking about with the jumping. Okay, all right. So, let's say I had something like 0, 1, 2, 3, 4, 5, 10, 11, 12, 13, 14, 15, 0. Okay. All right, so let's say I had that. So I know I want to count from 0 to 5, and then I want to count from 10 to 15, and then it goes back to 0. So really, what is happening here is not what y'all think is happening. Okay, so really this is a continuous sequence that only jumps right here, because at the 0 it comes back around. And so what you would want is you'd be loading 10, and detecting 5. Five is, let's see, what all would we need to detect 5? I think we would want these 3. can't get to my eraser. Won't let me move my recording thing. So I want to detect a 1 in Q0 and a 1. No, not that one. Okay. So I'm counting to 5 and then jumping to 10. Oh, I see. And y'all's also is only a 5-bit counter. Okay. All right. Let me think about this for a little bit, and then I'll post a video that has an example that will be very helpful for you. So rather than my just like sitting here and thinking for a minute and not coming up with something useful, let me think about it, and then I will post something that will be helpful. Okay, all right. But you do need to understand all of this to be able to get that far. All right, okay, you're welcome. Is that good, Miguel?
Yes, ma'am. That's kind of like the question I had, but it was my bad with my wording. But,
No, it was not. It was not your bad at all. I couldn't figure out what, because it was not, you were not the first person to have asked that. I think before you even joined us, I think someone had asked about it, and I didn't know what y'all were talking about because, yeah, bye-bye.